Hey there, Wild Ox Studios here, and today we're going to go over something a little technical, but I promise I'm going to try to make this as easy to follow as possible. Um, I did a video obtaining 90 frames per second in PCVR using Lumen with DirectX 11 and FSR 2.2, I believe, back in Unreal Engine 5.3. And there's been a huge amount of interest in um, what version of UE5 is, better to obtain PCVR quality, um, and also give you tools to have pretty good a pretty good anti-aliasing method and like cost performance savings to be able to attain a good frame rate with mid-range mid-range GPUs, um, and still be able to do global illumination. Now, if you're one of those people that are trying to do ArcViz and you're needing Nanite support, then this kind of applies to you too. So a lot of developers and studios that have reached out to me for consulting on that type of stuff, 5.3 has been pretty much the best or most stable way to achieve that if you didn't want to go source and you didn't want to have to deal with trying to fix either instant stereo not being right. In 5.4 there was a lot of like VSM shadow casting issues with instant stereo. There's performance issues with round robin occlusion querying. A lot of the VR index stuff was being worked on, as well as like your screen percentage. Like they were trying to unify screen percentage, so like upsamplers were crashing, DLSS was crashing in 5.4 and later versions. So there's been a little bit of turbulence along the path of trying to do something like this in later engine versions past UE5 3. There's also been, the PSO stuff with DirectX 12, and of course, if you're trying to do Nanite, you have to have VSM and DirectX 12 at SM6. So just keep those things in mind if you're on a Nanite, uh, you know, workflow or path as far as your goals. Now, the great news is, in the latest version of UE5.5.4, all of the VR, stereo instancing, shadow casting, a lot of that stuff's been resolved, as well as the unification, if that's even a word, unifying the screen percentage values for like upscalers, for like DLSS and FSR. So we're back to a place where I figured I would do what I promised, which was show an example of UE5 being able to do global illumination and hitting full frames with a decent AA method with Lumen. And what I have on the screen here is, as of now, DX11 and SM5 has been deprecated to some degree. I have two PRs open. Both of them were declined. A guy named Kevin in the PR basically said, main will have a CVAR to force this on in the future, but as it stands right now, they're pretty much focusing on moving Lumen over to SM6 entirely, and they're only supporting. So these are the changes that were made. They're only supporting Vulkan SM5 and Metal SM5 because there's hardware instabilities on SM6 with those devices, but they still want to support Lumen in these paths. So what I did was I defined a PC, a Direct3D SM5 platform the same way they did for Vulkan and Metal, and I added it to the OR statement to support Lumen and SM5 for DirectX 11 and 12. So I have this on my Git. If you're in the meta branch, you're likely on source anyway. You can just pull it over into your meta branch. But if you, and I think they're at 5.5.1 now as of yesterday, if you're in launcher and you don't want to go source, then you can lean on Vulkan on Windows. However, a little disclaimer here: DX12 and SM6 runs better with DLSS than Vulkan SM5. I don't know why this is. I haven't dug deep enough into it, but I do know that DirectX 11 is far more performant in SM5 than DX than Vulkan in SM5. It is just the way it is. And then in DX12 SM6 for Lumen, you can still hit frames. You can still do what you need to do, and you can still fall back to normal shadow maps. You don't have to use virtual shadow maps if you don't care about Nanite. So that you get a little bit of cost savings there, but it's not going to be as cheap. But yeah, if you want a DX11 and you want to be able to get the most savings out of this and not have to worry about PSO caching and fall back to that method, the code is here. You can see which lines you need to modify. You can see where it is in the render util CPP. You can just go apply this or look up my PRs and compile it out for yourself. Now we'll just jump right into the project. So a little bit of, I'm going to go over the majority of things that I've done here. In the previous project, what I did was I started with the VR template. But as you know, the VR template is built for forward rendering, so you have to go manually apply all of your RHI, deferred rendering instead of forward. There's a pretty lengthy process to get from forward to deferred and get all of your stuff right. So in this project, I took a bit of a different approach. I started with a third-person template because it's going to be set up for Unreal Engine 5 defaults. And then from the third person template, what I did was I then went and changed my RHI to DX11. I went and changed my SM6 support. Of course, in DX11, you don't have SM6, but I went and made sure that I was on SM5, in DX11. So then you just go to your shadows, and you want to make sure that maybe it's just shadow, your own shadow maps instead of virtual shadow maps, which by its nature, DX11 doesn't really support VSM. So I don't even know why it's not grayed out. I think in previous versions this would be grayed out. But yeah, just ensure that your own shadow maps are not VSM. And then, of course, Nanite's just not enabled on the meshes themselves. For VR specifically, you're going to want to go check on instance stereo. By default, these may not be enabled in the third-person template. So you're going to want this enabled. And then in round-robin occlusion queries, you can save a bit and make sure that that is enabled. So yeah, I'll let this restart real quick. So that's the things that you're gonna want to do just to get your project in line with, one, supporting the Global Illumination deferred rendering pipeline, and then two, having the cheapest baseline that you can hit with VR. Let me think if there's anything else. Oh yeah, when the project comes back up, actually I'm going to pause this to save some time. I'll take you through what I did inside of the map, because remember, the VR template is built in forward, so it's going to be stationary lit and it's going to be baked. So there's going to be the light maps that you're not going to want to pay for on your in VRAM, because you're going to want a dynamic scene. But I will take you through that process as soon as these shaders finish compiling. Okay, we're back. Shaders have finished compiling. So in your VR template map, first things first, you're going to want to go find your directional light, and you're going to want to set it to movable. And then you're going to want to find, actually, before jumping around, once you do this, also, you're going to want to come down to your shadow section, and by default, your dynamic shadow distance is going to be something huge, and your shadow cascades are going to be set to a value of 3. That's to save performance in forward rendering, because shadow cascades are a little expensive, and the less cascades you have, the cheaper it becomes. It's the same thing here. However, your distance is going to be able to be a lot shorter for dynamic shadows. And then down here, you'll see this distance filled shadow distance. You'll want to check distance filled shadows. What this allows for you to do is use distance fields at a distance. And basically with Lumen, this works anyway, because that's just the way Lumen works. It uses distance filled ambient occlusion. Once you get to a certain place, your shadows will not be covered by shadow maps, and this distance here allows you to fill in that gap at a distance. So yeah, you'll want to give yourself something reasonable there, so you don't have to worry with that so much. And these are far cheaper to do than paying for a huge distance on your CSM costs. So that's the 2 adjustments I did on the directional light. And then you'll want to find your point lights in the scene. There's these 2. Set them both to movable. One of them is going to have a pretty large annotation radius, but I didn't adjust it. But yeah, just make sure they're both set to movable. And then the next thing, you can delete the light mass importance volume that's going to be in the scene. I think it's like in this area here. You don't need it because we're not using baked lighting. And then in your light maps here, you'll see there's probably about 53, 56, something along those lines. You'll want to tick this force no pre-computed lighting, and then you'll want to come to build and build all to clear out your light map, so you're not paying for these textures in your VRAM. That's pretty much going to get you ready here. The next thing that I did was I pulled, and I don't want to say this level because I had everything set up already. I pulled a post-process volume into the scene because I wanted to fine-tune my Lumen sample and Lumen gather rate to be as cheap as possible. Again, we are in a VR project, so cost is, we're counting milliseconds here. So most of these point values are going to be about 0.5 values are going to be a default of 1. I just bumped them down to half. The Lumen scene view distance, because this is such a small scene and we're not doing vast areas of like landscaping, I bumped the trace and the scene view distance down quite a bit, and of course knock these 2.5 values down here as well. I don't need to mess with the color diffuse boost or skylight leaking values, so I just kind of left them to be their default, but I'll leave these up here just for a second for you guys to reference. The next thing, I've mentioned this in previous videos, but you'll probably want to go enable the CVAR viewer, just because this makes working within the editor session and seeing what different plugins and different commands are doing at runtime. So it's just a really easy way for you to be able to like go take a peek at what you're doing here in your console variables during your session. And with DLSS, this is fairly important, because you're going to be kind of play testing and looking at aliasing and looking at your temporal smear, and it just makes it really easy to keep up with that stuff. Now, on the subject matter of DLSS, so all you really need to do if I can spell, is be able to spell properly. That's what you need to do. So yeah, type in DLSS for UE5, come to NVIDIA's website, scroll down a little bit, and then it's going to be the first download the UE5.5 DLSS plugin. Now, once you have that in your downloads folder, and we'll go take a look at that here. I'll open it up for you. There's going to be some documentation that's really like, take some time and study it. It's going to help you understand what each CVAR setting for DLSS is going to do. And then you're going to have a plugins directory with a DLSS folder in it. This is your copy this out, and this is what you're going to place inside of your project plugins directory. You don't have to worry about these other ones too much. We're not doing a movie pipeline in this example, so the only one I grabbed was this DLSS folder. And in your my project's called Lumen Test, but slap that into your plugins directory, and you should be good to go. If you're on binary, you don't even have to rebuild this. It includes the binaries for you. You just open the project up. If you're on source, then in your project, you're going to want to go add a C++ class right here. Just make it an empty one, set it to public. It'll give you a solution like this when it gets done, and then open the solution in Visual Studio and rebuild for the plugin. Because otherwise it's going to warn you that it's not made for the version that you're running, because source is detected as a different version of the engine than binary, so or than the launcher build. And then after that, you're going to be pretty much ready to rock and roll. If we go into the plugins, you'll see that I already have it enabled here. So it looks like this, and by default you don't have to worry with it too much. Everything's gonna be just set up and ready to go for you. So if you come down to NVIDIA DLSS, you'll see it's already enabled for DX11 and DX12 RHIs, and DLAA is on for everything except for the editor viewport. So that means when you're testing MPIE, at least, you will see the advantages of it working. And then you could get crazy and adjust these presets yourself, but I haven't found a need to get into it all that much. The next thing is when you're testing, the great thing about unifying the screen percentages across VR and flat is that when you go to test, your scalability settings over here for your screen percentage is going to pretty much give you what you want to need when you switch between performance, balance, quality, native, etc. Or you can run the DLSS command for the preset. So if you just type in DLSS here, you'll see all of these CVAR values here. And there is parity between like performance and native mode with DLSS, so you don't have to worry about like passing these CVARs in directly, which is pretty nice. So for me, whenever I've been testing, I've just been hitting play in my VR preview, and we can just do the selected preview now. Actually, let's go select the third person game mode so that we have that third person character in the scene, and you can see like right away pretty good sharpness. And as I'm moving around, the smear it's nowhere near as bad as TSR. That's just something DLSS has always done better. It's still there, but it's fairly impressive. And we'll re-minimize and we'll go look at my settings here so you can see my, I'm at native with DLSS turned on. But let's say we go to balanced, or like let's do worst case 50%, which is performance. Even here, the reconstruction of the scene, I can see a little bit of artifacting between the light and dark areas, but it still does a much better job, in my opinion, than native TSR that's built into Unreal Engine. So probably why DLSS is the preferred upscaling method for NVIDIA users. Now you can still see like velocity artifacting on that yellow section of that cube as the camera moves around. It's not horrible. It's just a little bit of reconstruction on that. But I will say that like on flat, these little minute things with artifacting to the scene are not like noticeable by many, unless you're just nitpicky and your eye is trained to look for these kind of things on a daily basis, kind of like mine is. But in VR, FSR and DLSS artifacting is a pretty big deal. People, in deferred rendering, the reason why people go with forward rendering is because edge clarity is, it's a thing. So, how does it stack up against like normal TAA with deferred rendering? I would say if you tweak your TAA values, kind of like No Man's Sky or Skyrim, and you super sampled just a tad, and you were using like a cheaper SM5 DX11, normal deferred pipeline without Lumen, and you didn't have the Lumen cost, then you could obtain some really, really good results in deferred rendering. But the edge clarity that you're going to get out of DLSS, like even if you go play No Man's Sky, combined with a little bit of, lowering that native resolution and giving you some upscaling, is going to get you over that frame rate and give you the edge clarity that is kind of like this, I don't know, it's almost like this optimal place to be, where it's like you don't have too much artifacting going on. You get really sharp edges that you're used to seeing in a forward rendering pass, but you also get all the bells and whistles of ambient light that you get from deferred rendering. So let's get off into that. A lot of people want to know, like, why not stick with forward rendering? Well, let's think about like the forest. Let's think about Ark Survival. Let's think about No Man's Sky. All of these games have day-night cycles, which you can do in forward rendering. But the thing that they do really well that forward rendering can't do so well is they defer the occlusion of shadows and handle that in a very cheaper way, and you get things like screen space, ambient occlusion, or even in Unreal Engine 5's case, you get distance field AO, as well as you get distance field occlusion on the inside of areas like this. So your ambient lighting is far more detailed and just is of a higher fidelity and quality in the deferred rendering than you can achieve in forward. So it just kicks it up a notch as far as like those base building, like survival based games or whatever. So yeah, let's get to it. Let's like actually do some testing, because I'm excited for you guys to see this firsthand. And also keep in mind, like the example I'm about to show you, I'm on the Quest, so I probably need to take you through this. So the graphics preferences on a Quest when you're in Link is going to recommend you run at 72 Hertz. Now, there's a reason for this. Not to say that you can't hit 90, but when I'm benchmarking between Steam VR on my Vive Pro, which by the way is comparable to the Quest resolution, so it isn't like the HMD resolution is so drastically different that the cost, that the trade-off on the cost on the GPU is like trying to render to a higher res or something like that. So like the Index, the Vive Pro and the Quest are pretty comparable to each other. Quest does have a little bit more eye resolution, but nothing that's gonna like drastically change between like the Pro and the Index to where it's like gonna bump you down into reprojection. So just keep that in mind. The reason why the Quest recommends 72 hertz is because it's doing a compression and decompression of a codec signal that it's streaming to your HMD, and then it's running reprojection and AWS on asynchronous space warp on top of that, which is heavier in its nature, having to do all of that at 4128 by 2208. So if I run in Steam VR directly on my Vive Pro, which is what I did in the FSR 2.2 and 5.3, you'll notice that I was running natively at 90 hertz and not capping at 72. I just wanted to outline like that. This is why I'm testing natively on my Quest 3 right now, but I have tested on Steam VR and it's perfectly fine. You hit full frames no differently than I'm going to hit 72 hertz here. Just know that there is a little bit of an additional cost in running MetaLink because your GPU's gotta basically create a streamed feed and then send it over to the Quest headset to decompress. So just wanted to make sure I was covering all of my bases there. So yeah, I'm gonna pause the video right now and get the headset on so we can do some testing real quick. Okay, I'm probably not coming out of the right mic. Yeah, sorry about that. I had to get my mic closer to my face, so this is really weird. I got my headset on my head and I got my mic hanging, like my other headset hanging around my neck so that I can talk closer to the mic when I talk to you guys. So here we go. Let me get this pulled over my face. And we will give this a test. So we are here. Let's go ahead and pull up stat FPS real quick. And as you can see on the top right hand side, I'm at full frames. And I am running at performance mode, and edge clarity is pretty good. I'm dynamically casting shadows. Nothing is too crazy. And I'm recording in OBS Studio right now, without any issues. And this looks fairly decent. I can make out pretty much all of the edges on it, everything. It honestly, it is looking really, really good and has surpassed my expectations, even upscaling with DLSS, as far as like texture edge quality, and what I would basically be comparing to MSAA and forward. The other thing is like things in motion are looking really, really good. And as you can see, I've applied like this kind of glowy emissive material to my darts here, just so we can see like Lumen in action. The thing that I will mention that is a little strange, and as you can see, my point light over here is casting dynamic shadows on the wall. The thing that I noticed that's a little strange, and I didn't notice this in the FSR demo, but maybe it was happening, is that the screen space effects for the Lumen GI, they appear to render a little differently or do something a little different than like your ambient occlusion that's happening from your distance field. But it's not really a distraction. Like right here, the glow, you would expect it to be on the same vertex plane as the ground. Like you in VR, you would have to look at this with your own eyes, but like the glow, you would, in your mind, you would think in 3D stereo space, the glow would be aligned with the vertex normal of a surface, but that's not what I'm seeing here. Like on the ground here, when it glows, the glow is not presenting itself or projecting itself to the surface of the object, but because it's screen space, it doesn't understand the surface of the object. So it's just it almost feels like a flat plane on the surface of the screen that's just glowing around the object. But you know what? With all that aside, it's still not a huge distraction for someone who wants to go this workflow and still have Lumen GI. It's pretty nifty. I'm not super mad at it. And the effect tends to be more drastic over longer distances. And I guess that's just because the surface area is more massive. Whenever an object glows from a larger distance, you kind of get that larger screen space effect. Now, what I will say here, like, and I even think back to UE5 3, I will say that the GI has come a long way. The Lumen effects of this scene that I remembered seeing in FSR 2, maybe they've adjusted eye adaptation a little bit, but that's what I'm seeing here. And when I step out here, of course the eye adaptation, the exposure, fall off kicks in and things kind of dimming back up. But I will say, like, I'm fairly impressed. This is, I am comfortable in telling you guys to go forth and conquer in PCVR if Lumen and PCVR is your goal, and you're wanting to hit decent frames, and have a pretty good experience on the visual quality of what your upsamplers are going to do as far as being able to target this kind of workflow. Now, I'm going to hit Alt, pull up my engine, because I want to see what scalability we are running here. And this is at performance. I'm going to bump it up. Let's go ahead and go to like balanced, which is going to give me a little bit more native res. And we're still bumping into the 72, but I can see that we're still 72. It's kind of creeping into, like, I see 60 creeping in. And the funny thing is, like, it's not even, I'm asking myself, is it worth the difference that I'm seeing on the display? And I can't, that little added cost for bumping the native res up just a little bit, and bumping into reprojection in certain areas, like I just bumped into reprojection and just come down a second. I almost can't say that it's worth it. I would rather the higher frame rate. So, like, keep that in mind. People, like, of course, give them the DLSS options for upscaling, but I would say performance mode has enough edge clarity that you almost don't have to worry. And again, I'm on a 2080 Ti, so, like, higher end GPUs are going to have a much easier time with this. But I mean, this is great. Performance mode on this freaking 2080 Ti, even, it's fine. It looks perfectly fine. It's great. So yeah, that's my overview. I'm gonna hit stop now and then switch back over to headset. I mean, my actual audio headset. And I apologize for my fan going super crazy. So yeah, you can see I applied a projectile emissive material to the gun projectile just so I could play around with some of the glowing effects in Lumen. And let's go see if the console variable, like, I wanted to pop this up for you guys so you could see what the console variables were doing as I was playing in editor with DLSS enabled and adjusting my scalability. So yeah, I'm pretty excited to finally get this out to you guys and go over it. I can confidently say that I don't want to make this video go too long, but I did test DirectX 12 at SM6, and I can hit full frame. So if you guys aren't wanting to worry with compiling source to be able to get DX11 SM5, you know, on a 2080 Ti, which is, you know, it's a good GPU, but it, you know, the 30 series cards do DirectX 12 better than the 20 series. You should be fine doing DirectX 12 at SM6. Just keep all of the other cost savings things in mind that I mentioned in this video, and you should not have to worry about needing to go back to DX11. Just remember, PSO precaching is a necessity if you're running DX12. There's no way to avoid that. Anyway, I want to say thanks for all the to all the Patreon members for the Wild Ox Studios Patreon channel. Thanks to all of the developers, studios, and people who have been like really reaching out and suggesting stuff like this, content like this, and you know, offering me consulting gigs. Like, all of you guys are amazing. I love the Wild Ox family. I love everyone in the Discord. You guys challenge me to think about new problems that I alone would not find myself. So it keeps me kind of flexing my skill set. So you know, thanks for that. I want to say thanks to everybody who's joined the YouTube family. So you know, consider doing that if you haven't. If the content I make is adding value to you and your you know, your dev cycle in any way, shape, or form, and you'd like to return the favor, remember this, you know, incentivizes me to continue doing this type of thing. Hit that like and subscribe button, guys, if you haven't already. And until next time, happy developing and toodles.